Hey everybody, thanks for clicking on this video. Today we're going to be working with indefinite integrals with polynomial U-substitution. If you want to follow along, the links to the companion worksheet are in the description below. Also, if you want to see more videos like this, click the subscribe button so you can stay up to date on all the videos we have coming out from the channel. So let's get started. So with this first example, we have x times x squared plus 4 to the third power. Now U substitution is really just chain rule backwards. So U is just identifying what is the inside function, which for this problem is going to be x squared plus 4. So when we rewrite this, we take out x squared plus 4 and put U in its place. So it's x times U cubed dx. Next we take the derivative, so du equals 2x dx. So what we want to do is we want to put this entire integral in terms of just u. Now here we have an x and a dx. And over here we have x, we have dx, but we don't have 2, and we want this to match everything up here. So what we're going to do is we're going to take the 1/2, the 2, and move it over. So it's 1/2 du equals x dx. So now everything here matches everything up here. So we're going to take out x and dx and replace it with 1/2 and with du. Now the 1/2 is a coefficient, we'll put that out front. So now that everything is in terms of u, we can take the antiderivative. So that's 1/2 times 1/4 u to the 4th plus c. And we'll combine those two coefficients. So we have 1/8 times x squared plus 4 to the 3rd plus c. Number 2. Here, with this problem, the inside function is going to be 3 minus 2x minus x squared. But first, I want to write these two things out separately. When we have a quotient, it often is hard for people to see what's going on with u substitution. So we'll write this as x plus 1 times the quantity 1 over the square root of 3 minus 2x minus x squared dx. So u is 3 minus 2x minus x squared. So now we'll replace that. So we have x plus 1 times 1 over the square root of u dx. So next step is we're going to take the derivative of u with respect to x. So du equals negative 2 minus 2x dx. So we want to replace x plus 1 and dx with du. Now we don't have x plus 1. We have negative 2 minus 2x. So what we're going to do is we're going to divide a negative 2 over to the other side. So that means we have 1 plus x dx. So now we can make the replacement. dx and x plus 1 are right here, and we'll replace that with negative 1/2 du. So negative 1/2 goes out front, and so we have 1 over square root of u, or u to the negative 1/2 du. So now we can take the antiderivative. So negative 1/2 times, now u is going to be raised to the positive 1/2, because with power rule, the exponent goes up by 1. And then we have to have a coefficient of 2 out front, so that when the 1/2 comes down, it cancels out. Plus c. So the negative 1/2 and the 2 will cancel out. So we're going to have negative square root of 3 minus 2x minus x squared. Because that's what the 1/2 power means. It means square root. On the next example, u is going to equal x squared plus x over 2. And so when we make that replacement, we're going to have 4x plus 1 times e to the u dx. So when we take the derivative, du equals 2x plus 1/2 dx. Now, we have the dx, but we want 4x plus 1. So what we're going to have to do is we're going to have to multiply both sides by 2. to bump this up to 4x plus 1. And now we can make the replacement. 4x plus 1 and dx are taken out, and in its place we put the 2 out front and du. So now our antiderivative, e to the u, is just e to the u plus c. So that's 2e to the x squared plus x over 2 plus c. Number 4. Here x squared is going to equal u. So we write 5x sine of u du. dx, sorry, we haven't made that replacement yet. So then we have du equals 2x dx. Now we want 5x, not 2x. So first we're going to divide the 2 over. So 1/2 du equals x dx. And we want a 5. So now we're going to multiply 5 onto both sides. So 5/2 du equals 5x dx. So we can take out 5x and dx and replace it with 5/2 and du. The 5/2 will go out front. So we have sine of u du. So the antiderivative of sine is negative cosine. So negative 5/2 cosine of u plus c. And then we'll put the u back. Negative 5/2 cosine of x squared plus c. Number 5. Here's another quotient. So let's rewrite this. We have x squared plus 2x plus 3 times 1 over x cubed plus 6x squared plus 9x dx. So for this problem, u is going to equal x cubed plus 6x squared plus 9x. So when we make that replacement, we have x squared plus 2x plus 3 remaining times 1 over u dx. So when we take the derivative of u, du is going to equal 3x squared plus 12x plus 9 dx. Now we want x squared plus 2x plus 3. So everything here is 3 times too large. So I'm going to put 1/3 du, and actually that should be a 4. There we go. X cubed plus 4x plus 3 dx. So now we make that replacement with the 1/3 out front. So 1/3 times 1 over u du. So that's 1/3 ln of absolute value of u plus c, which is 1/3 ln of x cubed plus 6x squared plus 9x plus c. And then in our last problem, notice that x squared plus x plus 1 is the same for both of these. So that's what u is equal to, x squared plus x plus 1. So we have secant of u, tangent of u times 2x plus 1 dx. So the derivative, du, is going to equal 2x plus 1 dx. So that perfectly matches with what we want to take out. So that's going to be secant of u, tangent of u, du. And so the antiderivative of that is secant of u plus c. And we write that as secant of x squared plus x plus 1 plus c. Thanks for watching. If you liked the video, please give it a thumbs up. You have suggestions or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching. And remember, the best way to understand something is to do it.